Let's look at some easy redox reactions. So as a review, let's remember what oxidation and reduction means. We have our useful mnemonic, oil rig, and oil rig stands for oxidation is loss of electrons. Let's just make sure we know what we're losing. And reduction is gain of electrons. So when something is being oxidized, something else must be reduced. You can't have one without the other. And we call the thing doing the oxidizing agent. So the oxidizing agent is itself reduced. It is gaining electrons. So it is taking electrons from the thing being oxidized. So the oxidizing agent gains electrons, so itself is reduced. Its oxidation number goes down in the reaction. It's reduced. That makes sense, right? If the oxidation number decreases, the oxidation number is reduced. So that's how I remember which one is the oxidizing agent. Its oxidation number goes down. The reducing agent is itself oxidized. So the thing losing the electrons is the reducing agent because it's reducing the other thing, right? It's losing its electrons and giving its electrons to the thing being reduced. So the reducing agent is itself oxidized and loses electrons, and its oxidation number increases. So let's look at some example equations showing how we might determine which is which. Let's start with the reaction Cl2 plus 2Br minus goes to Br2 plus 2Cl minus. Okay, so the first thing we have to do is identify what the oxidation numbers are of all of the species in the reaction. So let's start with chlorine. Remember, an element on its own in its natural state has an oxidation number of 0. So chlorine right here is going to be 0. Let's look at chlorine on the other side. On the other side of the reaction, chlorine is now Cl minus, and the oxidation number of a monoatomic ion is equal to its charge. So it is -1. Okay, now let's look at bromine. So on the left-hand side, we actually have bromide, which is Br minus. Again, its oxidation state is going to be the size of its charge because it's a monoatomic ion, so -1. And then on the right-hand side, bromine, Br2, has an oxidation state of 0 because it's an element on its own. Okay, so let's have a look. What I like to do is kind of join the species from the left to the right, so we know that they're related, and I've done them in different colors as well. So chlorine was 0 on the left and it's -1 on the right. What did its oxidation number do? Did it go up or down? Its oxidation number went down, right? Its oxidation number was reduced. So chlorine was reduced. Bromine, Br minus, bromide on the left, became bromine on the right. So its oxidation number was -1 and now it's 0. It went up. So its oxidation number increases, so it was oxidized. Now remember, the thing that is reduced is the oxidizing agent. So Cl2 is the oxidizing agent. Br minus was itself oxidized, so it is the reducing agent. Okay, let's try another one. Let's do aluminum. So solid aluminum in a solution of copper 2+ ions will produce Al3+ ions plus copper metal, solid copper. Okay, so let's have a look. Let's assign oxidation numbers. So aluminum is in its natural state. It's an element, so it has the oxidation number 0. And then on the right, its oxidation number is +3. Copper 2+ on the left, +2, and on the right, it's elemental copper, so 0. Okay, let's look at the aluminum. The aluminum went from 0 to +3, so it went up. If the oxidation number increases, then it is oxidized. The copper was +2 and it went down to 0, so its oxidation number went down. It was reduced. Now the thing that is reduced is called the oxidizing agent. So copper 2+ is the oxidizing agent. Aluminum was oxidized, so that means aluminum is the reducing agent. And notice that on the reactant side, we have a reducing agent and an oxidizing agent, right? If you have one, you have to have the other. You can't have oxidation without reduction.